So now it's time to see if I can electrocute myself, or try not to electrocute myself. So I've got one of the DYN4s wired up through circuit breaker to the NEMA 23 size motor. I haven't plugged it in yet. I'm going to plug it in right now. And we'll run the software and see if it works. The .NET framework is giving me a hard time, so I'm not even sure if the software is even going to work at this time. So I'm going to plug in right now and we'll find out. All right, I plugged it in. Moment of truth. And we have power. We have power, and we should have motor torque. We have motor torque. Wow. It's installing device driver software, which should be on there, so everything's looking good so far. Things a little noisy. I guess we'll find out why in a little bit. All right, so we have to wait for the driver to install, so I'll come right back. All right, well that took longer than expected. This stupid laptop is giving me a hard time today for some reason. So it's all powered up, and I got the servo software going, so I'll go to connect, and I'll do detect COM port, and it'll tell me that the COM port that it found the drive on is COM port 3. And this is with the USB cable for motor tuning. So I'll select COM port 3 here, hit set COM port. And then from there I can go to, you can see the moving the mouse around and it's lagging. Go to servo setting. And go to DYN4, because that's the drive that I'm using. And I'm going to do a read to grab the base parameters of the drive. And then from there we can test it. We can just go to constant speed, bring the speed up. You can see the motor's turning. So everything's looking good so far. I'm just going to do this with all the other motors and drives to make sure that they all cooperate. And once that's done, once the initial testing is done and over with, then I can work on assembling my cabinet. Alright, so after much deliberation, this is my final layout. Or at least I hope it's my final layout. It's like my little mini metropolis of contactors and breakers and terminal blocks and what have you. So my thought is that my incoming power is going to come into the line reactor. Out from there, it's going to go to this terminal block here as 220. I will branch a leg off to here, possibly branch the other leg off to here, split it down the middle. That way I've got two banks of 110 off of the 220 that I can use to power each individual DYN4 for the 400 watt motors, because these drives and the 400 watt motors are going to run off of 110, whereas these ones are going to run off of 220. So I'm going to have the two hot legs of 110 coming in to here, drop down to here, branch off. Each of these terminal blocks are going to have the jumpers split down the middle. So I have 5 and 5. So I'll have 110, 110. Each one will have its own 110 leg down here through the contactors into each individual drive. The 220 will continue out from this block here to here and here, down into here, through these contactors to these drives. And also, as they come out of the contactors, they'll branch off into the smaller noise filters so that they can feed into the logic terminals on each one as well. "24-volt power supply is going to be up here. Power coming out of here can feed into here as well. This is a universal power supply, so it takes 100 to 240 volts AC. So if I run 220 into this, I will still get 24 volts out. And then I won't have any weird distribution between the two 110 legs that are coming in. So I'm trying to keep it as balanced as I can. So the 24 volt will come out of the top of the power supply, come down to these blocks, and these are just going to be my 24 volt positive and negative. And then from there, that will feed into the field I/O, which gives the Mesa board power. I've got a couple of cheapy relays that are right by the I/O. I've got this green block here and a couple of these ground blocks. The ground blocks will utilize the DIN rail as a grounding source. And then I'm going to put a jumper into the green block, and then I'll have these terminals all connected to the grounding blocks to supply ground to not only each of the noise filters, because they each have their own individual ground, but also the drives, because the drives also have grounding points as well. So that's my thought. So my incoming is going to be hot, and then my ground lug is going to tap into this guy right here, because this is a grounding source. And then from there, the ground should be distributed through all of the rails and whatnot, because this is a steel plate, so there will be ground continuity between the entire assembly. So hopefully that'll work. We will see when I start wiring it up. So I just want to go over some changes that I had to make to get my Mesa 7i7-6E to connect to my laptop. So I connected the wired connection from the Ethernet port of the laptop to the 7i7-6, and I connected 24 volts to the RS422 and the field I/O power, which powers the entire board off of the 24 volt instead of having to do a 5 volt into the little terminal on the end and stuff like that. So once I got the card to fire up, I couldn't get the Ethernet to communicate. So 2 reasons. One, because I have a Wi-Fi network on this laptop, and the Wi-Fi network is set to a conflicting address. It was set to 192.168.1.1 as the gateway, and the standard connectivity crap. So to get around that, what I did was I moved the jumper W2 and W3. If you follow the instructions for moving the jumper, to set it to use the IP address of 10.10.10.10 for the card. So that's what I did here. I moved the jumper, restarted. Then what I had to do is I had to go to my network manager, and under Ethernet network, it said that this connection is not managed. So to get around that, I went to Applications, File Manager, File System, ETC, Network Manager folder, and this Network Manager comp file. To open that, go to Terminal, type in sudo mouse pad. If you have gedit, I think you can use gedit. Drag the file in, and this if up down, the managed was equal false, change that to true. Save the file, close it out. Then in terminal, go sudo service network dash manager restart. That will restart all of the network services. It'll add the wired connection to your network manager. If it doesn't connect instantly, then right click, go to edit connections, add a connection. In my case, I called it LinuxCNC. The device is the ETH0 or Ethernet 0 device. I don't know if the MAC address thing makes a difference, but I had it set to permanent, and that's what seems to be working right now. So, but under IPv4 settings, I went to manual, added an IP address. The IP address for the computer is 10.10.10.2 with a net mask of 24, a gateway of 10.10.10.1, DNS server of 10.10.10.1, hit save, and everything connected hunky-dory. And then when you do your PNC conf, you might have to go into the HAL file and change the configuration address to 10.10.10.10 to connect to the card when you fire up LinuxCNC. I'm not connected to my board right now, so I'll do another video and I'll show you the connections for that. All right, so I'm at my board now just to show you. When you're not connected to LinuxCNC, you're going to see that amber light, and you'll see the little green lights. They kind of dance around. That just means that you have a network connection, but you're not connected to LinuxCNC. So when you go to, I discovered just now, when you go to LinuxCNC, if this thing would fucking focus. Once it gets the full connection to LinuxCNC, the green lights actually just light up solid, and then you get rid of that amber light. So that was my mistake. As far as all the other connections are concerned, you know, I got this going on here. And if you need a 5-volt supply from any of your motor connections, the leftmost and the rightmost on each one are your positive and negative for 5-volt. So if you need 5 volts going to anything for your, motor enables, whatever, that's where you would get that from as well. And to change your configurations after you do your PNC conf, every time you run that, it's going to overwrite any manual changes you make. So make all of your changes in PNC, and then once you have to make manual changes, then you're kind of screwed. So you want to get the PNC thing configured to where the machine is almost perfect, but then you have to make minor tweaks. But to get to that, applications, file manager, LinuxCNC folder, configs, the name of your configuration. Then you have a whole slew of different files that you can crack open and mess with. The two that you're going to mess with the most, well, the one you'll mess with the most is going to be the HAL file, but the INI file is where a lot of your motor settings and things get stored. The HAL file is for creating physical connections to virtual pins. That's a little bit more in depth than we need to be right now, but if we go into mini-mill INI in my case, you'll see that there's a lot of settings here, but as we go down, We'll get down into the axis settings for each motor. Here's your step scale, your direction setup, your direction hold, step length, step scale. These are the values that you change in that little box up to 10,000. Here you can make them whatever value you want, but on the PNC conf, it limits you to 10,000. You can make them 20,000 here. You just have to go down through each one, find the scale, and just change them there. Alright, so I just want to go over a little bit of what's going on with my spindle. So I've got the 1 kilowatt DMM servo with the DYN4 drive. Got everything all wired up. It's a little bit of a spaghetti mess right now, but when the top covers go on, it'll clean it up a little bit. For external power, for the time being, I've just tapped into this will eventually be my 220 terminal block. But right now I've got it feeding 110 and then feeding out to just this outlet that I had. Eventually the orange block is going to be feeding 2 different legs of 110. A leg here, going to the individual drives for my X and Y. So my X and my Y are going to be on 2 different, I guess you would call them phases of my 110. I just call them legs because it's still a single phase, 220, but it gets divided up 110, 110. And then the return is going to be this green guy here. That's going to be my neutral return for my 110 circuit. But anyway, I got 110 feeding out to here so I can charge my 2 computers. I've got this laptop running LinuxCNC. Got this laptop running Windows, and I've got it running the DMM software. In the DMM software, if I connect to that, and I just know COM port 1 is going to work. When I go under servo setting, select the DYN4. When I go to read, it's going to read off of the drive that's plugged in. And it's going to tell me that I have this set up for active low. Active low just means, and that's what I wanted to show you, the servo active low on here means that when this fires up, it's not in power mode. When I go to LinuxCNC, load this up, boop, 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 boop. All right, once that fires up, when I release E-stop and then I do the machine enable, now I've got motor torque. So I've got the spindle set up right now to only enable when it receives the output signal. And then I've got the alarm circuit hooked up so that when the motor, or if the motor should trip out, it feeds the alarm signal on the board, and then the software will stop. If I just take the machine out of enable, it freewheels again. This will be good for when if I ever want to indicate a bore and I'm not using my probe. There's no really any other reason for it, but so what I did have to do, I'm going to show you this here. If I go to M3 S100 and I enable Spindle, crank this up, 2000. If I M5, right now it's just going to coast down to a stop, and that's it. And it's happy. In order to get the software to coast down, what I had to do, there was a thread on the LinuxCNC forum that I had to find. I posted a question about it, but then I found the answer. I have it in my custom post HAL right now, because when I'm done with the actual setup, I'll copy all this into my main HAL. But I had to find this bunch of HAL code in order to set up the deceleration. The acceleration was set up in the software, and then it accelerated just fine. The deceleration, it would just come to a screeching halt, and you can't have that. In my main HAL, I had to go into my Spindle settings, and I did have to change a couple of things. I had to disable a couple of the Spindle pinouts. Where are they? Here they are. Disable a couple of the Spindle pinouts because they were being used by that HAL file. And then there was some nomenclature that had to get changed to work with my 7i7.6 board. I think the code was written for a 7i4.3. I still have to dig in and see what's going on with all that. But that is how I got it to ramp down. There's also some INI stuff that I put at the bottom for, I guess there's a ramp curve, and then there's an off delay, which gives me 5 seconds of delay time before the motor decides to lock up. But because I closed out LinuxCNC, duh, it's not there anymore. It's not engaged. So let me fire this back up. All right, take it out, and then we'll go MDI, crank it up. So if I M5, it winds down. But then once it winds down, now the motor's engaged again. I haven't checked to see what happens if I disable the motor. Whoops. By doing a, so if I actually e-stop the machine, it'll come to a screeching halt. I don't know if there's a way around that, but I guess we'll jump off that bridge when we get there. But if the machine gets e-stopped, as it is right now, the spindle will stop solid. So hopefully I don't have to e-stop the machine while I'm cranking at 5,000 RPM. But one thing at a time.